Okay, hello everyone. Today, the topic of my speech is the application of bile acid in the raw fish meal diet of shrimp. The speech divided into three parts. The first part is reason and problem of fish meal substitution. This is why bile acid are added to reduce some of the negative effects of post replacement. The second part is the mechanism of bile acid. In this part, we will know what is bile acid and how does it work in animal body. The third part is study on bile acid in raw fish meal diet of shrimp. In this part, we will learn more about the benefit of adding bile acid to shrimp in raw fish meal diet. Let's get to the topic. The first part is reason and the problems of fish meal substitution. Fish meal is an important animal protein raw material in shrimp feed. It has many advantages, such as providing high quality protein, balanced amino acid, low anti-nutritional factors, high micronutrients, high health, high digestibility. Estimated global use of fish meal within compound aquafeed. A quarter of fish meal is consumed in shrimp feed. With the growth of shrimp feed, the demand for fish meal will further increase. In recent years, global fish meal production has declined from 5.6 million tons at the peak to less than 4 million tons, has dropped 33%. However, the whole trend of fish price is rising due to the decline of global fishery resource and growth in aquaculture increase demand for fish meal. Rising fish meal price lead to high feed cost. How to effectively deal with this situation? Therefore, we must reduce the amount of fish meal used in feed, thereby reducing the dependence on fish meal and the cost of formulation. Traditional fish meal replacement method is using the other protein source and supplementation with limited amino acid. Diets must be developed based on substitutability and plant protein source could replace the amino meals, especially fish meal. This plant protein include soybean meal, cottonseed meal, corn protein, canola meal, and so on. In the future, the proportion of plant protein in feed formulation will increase from 53% to 69%, while fish meal will decrease from 31% to 10%. What problems with fish meal substitution? Take soybean as an example. Soybean is an important source of plant protein for humans and animals. It contains 20 to 25% oil and 40 to 48% protein. It's rich in vitamins, trace elements, and balanced in amino acid. However, soybean contains various anti-nutritional factors, such as protease inhibitors, lectins, and phytic acid, which can reduce the palatability and hinder the absorption of nutrition. Plant lectins can destroy the IgA produced in the intestinal, which damage the immune system and reduce immunity of the animal body. There is a lot of researchers on fish meal substitution, but the substitution is not a simple matter, and there are many factors and need to consider. Therefore, a comprehensive replacement strategy for fish meal is urgent needed. What has negative problems of fish meal substitution? First, metabolism of various nutrients are suppressed in shrimp feed, the low fish meal diet. Glucose, triglyceride, and total bile acid metabolism showed a significant downward trend. 我可以用鼠标吗？ Okay. Second, the immune response was suppressed in shrimp feed, the low fish meal diet with the increased fish meal replacement amount. The lesion of hepatopancreas and intestinal tract aggravated, and the health index decreased significantly. Third, induce enteritis, such as the increased expression TNF-alpha, destructive junction protein, increase intercellular space, and makes the gut lose its barrier function. Shorten of the intestinal villi and thin of the intestinal wall. Extract mechanism is unclear, but TNF-alpha is associated with MLCK. And so do we have feed active, which could improve the lipid metabolism, immune response, and reduce the interest of shrimp. The answer is true. Add bile acid to feed. Bile acid plays an important role in digestion and absorption. It can serve as a critical signal marker in regulation. Immune response is also a major regulator of the gut microbiome. That fish meal alternative often disturb bile acid status in fish, resulting in increased or decreased intestinal response, reabsorption, and bile acid synthesis. It may be magneted by processing of fish meal alternative, as well as the dietary inclusion of some bile acid. Although bile acid is traditionally regarded as an synthetic in crustacean, a few recent study has reviewed the critical role of bile acid in the diet of shrimp. What is the bile acid? It produced in the liver with the action of 7-alpha slates with cholesterol is used as raw material, which can regulate the metabolism of glucose and lipids, protect the liver, and regulate the balance of intestinal flow. Acid, which widely used in the treatment of human liver metabolic disease. And how does the acid work? Promoting fat digestion and absorption is the basic function of the acid. This process divided into three stages: emulsification, digestion, and absorption. In the emulsification stage, acid contain lipophilic groups which can emulsify large fat into small fat droplets. In the digestion stage, acid can increase the active of lipids, change the spatial structure of lipids, expose the catalytic group, and decompose fat into free fatty acid. In the absorption stage, acid and free fatty acid form mixed microcells that are recognized by the villi of the small intestine and into the intestinal lumen. Then free fatty acid, protein, and the triglycerides from and into the blood circulation and complete the entire process of fat absorption. In recent years, studies have shown that acid also play a role in maintaining intestinal barrier function. Acid as TGR5 receptors can activate intestinal stem cell and promote the differentiation into intestinal villi cells. Stem cell maintenance and injury-induced regeneration. We can summarize the function of acid: lipid digestion, absorption, absorption of fat soluble nutrients, regulation of cholesterol levels, and gut microbiome. Through the study of the acid in shrimp raw fish meal diet, we can understand the role of acid in diet. Three nitrogenous and also lipidic diet will formulate in this study. A positive control diet with 25% fish meal, a negative control diet with 5% fish meal, and 10-5 fish meal diet supplemented with acid. Fish meal was replaced by soybean protein concentrate. Is in this study, raw fish meal diet were supplemented with macronutrients such as amino acid, vitamins, and minerals to obtain a similar nutrition profile to diet high fish meal. Acid with poultry 98% was provided by standalone animal health products, formulation and promate analysis of the data was presented in left table. Shrimp and experimental contains the average intestinal weight of shrimp is 0.3 gram. For replace per treatment, feed 3 times a day. The breeding cycle is 8 weeks. The water quality is the most suitable for shrimp. Let me see the result. The final body weight, WG and the FE were higher in shrimp feed without high fish meal than those fed without low fish meal, and there was no difference between shrimp fed without low fish meal with bile. Survival of shrimp was similar among the 3 groups. Previous research revealed that the plant protein often disturbed the bile status and reduce fish productivity and anti-nutritional factors and high molecular protein are believed to contribute to it. This situation could be mitigated by the dietary inclusion of some bile. It was shown that the supplementation of bile to the low fish meal diet promoted the growth of shrimp. Low fish meal suppressed the hepatopancreas mRNA level of SOD and inhibitor of apoptosis protein. Dietary supplementation of bile in a low fish meal diet enhanced the express of SOD, CAT, and release in hepatopancreas, even showed higher CAT expression compared to shrimp fed without high fish meal. In the expression of Xbox binding protein and K-space among the 3 groups. Intestinal immune response. Shrimp fed the diet of low fish meal showed the higher Xbox binding protein expression compared to the fed diet high fish meal. Dietary supplementation of bile in a low fish meal diet enhanced the expression of SOD, CAT, and relish in the mid-gut. The mRNA level of SOD and CAT were higher, and turbo was lower in shrimp fed without low fish meal compared with the shrimp fed without high fish meal. There are no difference in the expression of ERK among the 3 groups. Dietary bile supplementation regulated the SOD and the CAT expression in the hepatopancreas and the intestinal, which indicated that the bile supplementation enhanced the antioxidative ability of shrimp. Dietary supplementation of bile in a low fish meal diet reduced the ER stress in this study. Hepatopancreas and intestinal histology. B cell was similar, and R cell was fewer in shrimp feed, the low fish meal compared with the shrimp feed the other diet. Intestinal follows hair was shortened in shrimp feed the adult low fish meal compared to the feed the adult high fish meal and the low fish meal with the bile. TEM analysis demonstrated that the mid-gut suffered the more serious damage in shrimp feed diet low fish meal, especially for which was ovarian swollen. The was back to the house after dietary supplementation with bile. Hepatopancreas B cell is the secretory cell, and R cell is for storing nutrients. Fewer R cell in the hepatopancreas or shrimp feed the low fish meal with bile indicate that the nutrients storage was decreased. Nutrients may be fully mobilized to support the max growth of shrimp. Intestinal microbiota, as shown the signal index was higher in shrimp feed the adult high fish meal and the low fish meal with the bile than those with the feed the adult with low fish meal. And the Simpson index was lower in the shrimp feed the adult high fish meal and the low fish meal with the bile than those feed the adult low fish meal, which indicates the lower bacteria diversity in group low fish meal. Dietary supplementation of bile in a low fish meal diet increase the community richness CHL1 and ACE of shrimp. There are no difference in autos numbers and coverage among the three groups. Anyway, undesirable intestinal microbiota community are induced by high plant protein. The analysis of PCOA showed that the first two principal components explained the 45.9% of the variation, and there was a clear separation between the three groups. The relative abundance of gut microbiota in each group at the phylum level is shown in Fig C. The diamond phyla in the three groups are Bacteroides, Cyanobacteria, and actin bacteria. The relative abundance of actin bacteria was exceed 18% in all groups. The relative abundance of gut metabolic at the diner's level is shown in Figure D. The demand diner in the three groups was Vibrio, Rugeria, Sima, and the Helocysibacter. Vibrio is a kind of typical harmful diarrhea
The present result indicate that the higher vibrio abundance may associate with the intestinal inflammation induced by plant protein. Dietary supplementation of bile may be reduce the intestinal damage by reducing the abundance of vibrio. Rugeria is involved in protein utilization. The higher Rugeria abundance may associate with the growth promoting effect of bile. It's also regarded as a kind of probiotics in shrimp. The higher abundance of Rugeria in shrimp feed dealt with low fish meal bile may be beneficial to the intestinal health of shrimp. As shown in figure, dietary supplementation of bile in low fish meal diet significantly decreased the relative abundance of proteobacteria. Dietary bile supplementation also increased the relative abundance of Dada bacteria. Besides the relative abundance of cyanobacteria, Dada bacteria was here in shrimp feed that dealt low fish meal with bile compared to the shrimp feed the high fish meal. Significant feature of 1250 genera were analyzed in this study as shown in figure. 17 genera was significantly affected by the delta treatment. 14 of them belonged to proteobacteria. 3 of them belonged to cyanobacteria. The relative abundance of vibrio were higher in shrimp feed that dealt with low fish meal than those with feed the high fish meal and the low fish meal with bile. The relative abundance of Rugeria was lower in shrimp feed that dealt low fish meal than those feed the low fish meal with bile. These results indicate that the low dietary fish meal level increased the harmful bacteria genera and decreased the microbiota diversity. Dietary supplementation of bile could decrease the harmful bacteria abundance and improve the microbiota diversity. Bile are receptors of TGR5 and FXR, which can inhibit the NF-kappa B signal pathway, thereby reducing the expression of pro-inflammatory factors in intestinal cell, thereby inhibiting enteritis and maintaining of the function of the intestinal barrier. Conclusion: low diet fish meal 15% decreased the weight gain, impaired the immune ability, induced the intestinal damage, and disturbed the intestinal microbiota of vitamin. Dietary supplementation of 0.1% bile in raw fish meal diet can enhance the antioxidative ability, reduce the ER stress, improve the microbiota diversity, and decrease the harmful bacterial abundance of vitamin. Many studies show that the bile is also good for fish and benefit for the growth, lipid metabolism, and the composition of gut microbiota, but depend on fish species bile level. Our partners are located in more than 40 countries around the world. Our company is committed to the creating wealth for 6,000 feed companies and 10 million farmers. Looking forward to cooperation with you sincerely. Thank you.